So welcome to our February Physics Matter edition. So let's continue our international year of basic science and sustainable development on positive note. So last month, we have visited Singapore to explore the world of dimensionality and graphene. So with Professor Antonio Castro Neto, gathering a large audience from more than 34 different countries, and even more thanks to our recording. But today, we will explore the dimension time by returning to the cradle of civilization and more light source scientific case live from Cyprus with the SESAME in the Middle East. So Professor Kirsi Lorentz will explain how physics matter in bioarchaeology. So let's recall also first our first live Physics Matter colloquium in March 2021, as Professor Claudio Tunis from the ICTP presented how physics can measure tempo and model in human evolution. And it was the celebration of the 150th anniversary of the Descendant of Man by Charles Darwin. So it's all available in our website, and you can see those recordings. Very precious information as well. So let's introduce our FIP panel member today. So my name is Christine Dar. So I work at the European Spallation Source in Lund in Sweden, and I'm the chair elected of the FIP. We have also Joe that will meet us a bit later. So Joe Nimela from the ICTP in Trieste, who is the chair. Alan Hurd, who is the past chair, and Luisa Cifarelli from Bologna University, who initiated this Physics Matter series. So, and we'll connect, and who is already now available. So we have Andrea Lossi, so I just shared now with you, who is the science director of the SESAME light source. Today's speaker will enlighten all those different potential of the SESAME. So this is why it's important to return to this Middle East with the quest to understand more human heritage, mankind, or rather humankind. So with its connection and its complex aspect. So this is a very nice reflection as well and material for our April Physics Matter Forum, where we are planning to discuss how science can facilitate human heritage. So for Professor Kirsi Lorentz, so she will explain today how physics matter in bioarchaeology, studying metals, human health, and beyond. So Professor Kirsi Lorentz received her PhD from the University of Cambridge in 2004 with focus on human bioarchaeology. Prior to joining Cyprus Institute and its Science and Technology in Architecture in Archaeology and Culture Research Center. So she was the director of the Ofson Bioarchaeology Laboratories and tenured facility in Newcastle University. So her current research focuses on synchrotron radiation, enabled bioarchaeology, as well as other scientific and technological means to approach the key question regarding human past through archaeological human tissue. So she currently leads analyses on human remains from the wider Eastern Mediterranean and the Middle East, so the EMA, the region and what is around it. So it includes Cyprus, Iraq, Syria, Turkey, and Iran. And her particular research interest include human metal exposure in the past through focus on ancient human tissue and microstructure. So she currently leads two large external fund projects with academic and industrial and government partners. And she's a member of the Cyprus government delegation to the SESAME Council. So additionally, she served as the vice chair of the steering committee for the European Union for the Horizon 2020 project BITS, and building as well all those different tomographical beamline at SESAME, so the synchrotron, and she's the chair of the LIPS, which is the light source usage and strategic plan committee for the Middle East. And so as a role model also, this is an important fact that she has led the first official user group at the newly opened SESAME synchrotron. So before we start, so we will look a bit at the logistics. You have so the different possibility to raise your hands or to ask a question. So in the question and answer session, so best to keep them for the end. I think it will be a nice possibility then to further interact. And then so we can have the floor then given to Professor Kirsi Lorentz for her nice presentation. And you can share the screen. Thank you so much.
What if there were no metals? Imagine your day without metals. Physics matters in bioarchaeology. What I will talk about today relates to our use of metals, a central aspect of our human civilization. And first of all, I would like to thank Christine for inviting me to this Physics Matters series, as well as all those who are involved with the Forum of International Physics, APS. It's a great pleasure and an honor to talk to you today about physics matters in bioarchaeology and look at our common human past. And I hope to tell you a good story as we go through the day today. So let me start by putting things into context. I mentioned metals, and I asked you to imagine one day of your life without metals. Rather difficult. Exploitation of metals is at the core of our civilization, one could say. Metals enable us to do many things critical to our existence today. However, metal exposure has affected humanity since the first exploitation of metals, and indeed is very topical today. Health is, of course, a critical factor for individuals, societies, and economies to thrive. And therefore, today I would like to take you on a journey through the past in the EMMA region, Eastern Mediterranean and Middle East, where also SESAME synchrotron is located, and look at metals and human health in the past. Metals such as lead, copper, and arsenic, which is of course a metalloid, were mined, manufactured, and used at ancient archaeological sites. They also enabled technological advances. Further, cultural aesthetics led to the use of heavy metals in pigments decorating artifacts, but also in cosmetics for enhancing personal appearance. Now, where physics comes in is how we start looking at these processes in the past. Synchrotron-light enables us to explore human metal exposure in the past. And the techniques I mentioned here on the slide can be used to explore not only the presence, but crucially in the context of human health, the speciation of heavy metals in ancient human tissues, which has a critical effect in terms of health consequences. What I particularly look at is a range of human tissues that preserve from the past to us: bone, dental tissues, hair, and skin. And to contextualize it further, public health is, of course, all around us. The water we drink, and very topically today, the immunizations we receive to prevent illness, and the environment which we live, work, and play in. In the past, environmental factors, human activity, and even cultural aesthetics would have affected the exposure of individuals, but also populations to metals. So we'll go through today briefly, what is human bioarchaeology? Why and how does physics matter in this domain? I look at role of SESAME synchrotron together with you, and briefly have a look at metal exposure in the modern world, and particularly in the SESAME region. And then we'll launch into the case studies on metals, health, and beyond, using synchrotron radiation-enabled human bioarchaeological approaches to look at three different localities in our region here in the Eastern Mediterranean and Middle East, and metals and health in these contexts. And I'll close with some future prospects. So let's look at what is human bioarchaeology. It is the study of human remains from archaeological contexts. This field emphasizes interdisciplinary analysis, the links between biology and culture in past societies, and can contribute to an informed understanding of the range of social, behavioral, and economic conditions and circumstances that have shaped our human experience. Such things as well-being and health, lifestyle, quality of life, and this during the last 10,000 years of human evolutionary history. And in its interdisciplinary aspect, it integrates all humans' current knowledge and techniques to investigating all humans' past activities, knowledge, and techniques, including also synchrotron radiation-enabled approaches. So I mentioned that human bioarchaeology studies human remains from archaeological sites. We have different scales of analysis. We can look at particular questions of importance at population level. We can look at various issues at individual level, look at life histories, so-called osteobiography. And we can also look at questions at tissue level. And this is where synchrotron radiation really comes to the fore. Our most direct avenue to access information on past people is indeed the remains of our ancestors. Looking at their health and disease status, activities, lifestyle. Bioarchaeology, as opposed to human bioarchaeology, can also encompass animal remains, plant remains, any organic remains, really. And here's some of the examples of those organic remains where synchrotron radiation-enabled approaches have been undertaken to explore important questions about preparation techniques or domestication of particular plants. Now, why and how does physics matter then in human bioarchaeology? And just to remind ourselves, and here's a definition from Britannica, physics is concerned with all aspects of nature at different levels, including the submicroscopic. Behavioral objects under the action of given forces, including electromagnetic, is some of its foci, and indeed brings us to looking at synchrotron radiation and how we use it in human bioarchaeology. And here's some of the forms of that radiation that have been applied. X-rays much more prolifically in human bioarchaeology than synchrotron radiation. Here's a very quick recap. Röntgen, of course, took images of the human body or parts of it. And here's some of the examples. And interestingly, his discovery, X-rays, were used for archaeological human remains very soon after their discovery. Here are some images of the mummy. We're really looking at just a few months. Now, looking at conventional X-rays in human bioarchaeology, these can be applied, of course, in the laboratory, but also in the field. And we can look at a number of different issues as noted on this slide. The X-ray systems are extremely useful in assessing material, both in the field and in the museum. And further field-based X-ray techniques in terms of CT, portable X-ray fluorescence approaches, and so on, are useful for looking at pathological lesions at larger scales, as well as the first characterization of elemental content prior to taking material to synchrotron radiation facilities. There are limitations, however, as I note there. Now, synchrotron radiation has some benefits, advantages, if you like, over conventional X-ray sources. High flux, brilliance, temporal and spatial coherence. And the development of high-resolution detectors has made it possible to implement various imaging techniques where we can look at both structural and chemical imaging. Here's some of the techniques that have been used in archaeological science. Not all of them are regularly applied to human remains. When I talk about archaeological science, I'm referring in general to scientific approaches to any archaeological materials, material culture, and so on. Just a few notes on some of these techniques, and there are many different resources that you can, of course, follow up on, looking at microcomputed tomography, as well as just noting in this context the BEATS project that Christine already also mentioned. BEATS is constructing a beamline for tomography at the SESAME synchrotron. And this is aimed at serving user communities in the region and beyond. And in particular, cultural heritage and archaeology is mentioned in this context. One thing that I would also like to draw attention to is the importance of the succession, the progression from the field through laboratory analysis and sample preparation to the synchrotron, with the very few samples that present unanswered questions still after investigation with such facilities as, for example, the platform for biosciences and human health in Cyprus, the Biomera project. And here I would really like to draw your attention to the progression from, if you like, from dirt to ultra clean facilities, the excavation on the left, all the way through inventory, morphological analysis, macroscopic analysis, to microscopic analysis at high resolution, structurally, chemically, at the laboratory context, and then identification of those samples that require synchrotron radiation analysis, preparation of those samples, and then finally culminating in beam time at a synchrotron radiation facility and at an appropriate beamline. Here, SESAME and our colleague Mesut Harfoush at the XAFS XRF beamline with our team. So here are some of the principles of the SR-XRF technique and the infrared approach. And in the synchrotron context, you can see the outstanding results on that image there, comparing synchrotron and globe sources. And in many contexts, this is critical for us when we are looking at archaeological samples, often very heterogeneous, very challenging, and being able to have this resolution and approaches in non-destructive way is really critical. So in terms of what the research foci to which we can apply synchrotron radiation in human bioarchaeology, what they encompass, we can look at paleopathology, pathological lesions in archaeological human remains. We can look at virtual histology without cutting the samples using micro CT with synchrotron source. We can use this in age estimation, critical to some key archaeological questions. We can explore state of preservation of these remains. And finally, a number of key archaeological questions can be answered with a combination of methods, including synchrotron radiation, and today focusing on metal exposure. Role of SESAME, I'd just like to point out the culturally rich, archaeologically rich region. These sites that SESAME is located in, these sites, many of them UNESCO Cultural Heritage Sites. And in addition to this, SESAME is located in an area commonly known as the cradle of civilization and very close to the area known as cradle of humanity. And together with the ongoing African Light Source project, SESAME has an increasingly big role in exploring the cultural heritage of the region without the necessity to take the remains away from the region into third countries. SESAME is a third generation synchrotron light source, and it was officially opened in Al-Ain, Jordan in 2017. And here's some of the beamlines, and I'd just like to highlight the infrared beamline, as well as the XAFS XRF beamline and the tomography beamline to be built. All of these are critical to cultural heritage studies and human bioarchaeology in particular. And I'm particularly pleased to note also that the first official beam time at SESAME was on ancient human remains from the SESAME region. And this is particularly pleasing because it draws attention to the contribution and role of SESAME in cultural heritage archaeology and human bioarchaeology in particular. Now let's look at metal exposure in the modern world. Here's something from the CNN. Look at the image. A mother, perhaps, and her child crushing stones. After the cobalt is mined, it has to be washed, sorted, and crushed. This way of doing things exposes individuals to chronic exposure to cobalt particles, which can cause respiratory disease and skin disease. Heavy metal toxicity is a research domain. Also, a particular focus there is on abnormal growth and development in terms of human fetuses. Heavy metal exposure in Africa is extensive. Here, just examples from sub-Saharan Africa, which has become heavily polluted with heavy metals and other chemicals from zinc, lead, aluminium, cadmium, nickel, iron, manganese, and arsenic. And heavy metals contaminate both the surface water and underground water, soil and food, thus affecting biological function, endocrine systems and growth in terms of humans, but also other animals. Now, this is, of course, an issue that is cross-cutting, not only in Africa, but also in terms of, and here you can see a paper on road dust, where highest zinc contamination was observed from road dust in Europe, followed by Asia, Africa, Australia, and America. What about the Middle East? A couple of examples here. At Saudi Arabia, there's a paper on toxic metal ion contamination in the groundwater, and Egypt, where an exposure assessment of heavy metal residues was conducted in fruit and in particular in grapes, where estimated daily intake of heavy metals based on fruit samples is higher than that of the tolerable daily intake. And here's just some of the flowcharts on groundwater pollution sources. More about sources. Some heavy metal exposure sources in our region include mining, lead poisoning from eye cosmetics. Galena is something that is widely used both in the past and in the present, known as kohl, kajal, surma, depending from the cultural contexts. Hair care products, other cosmetics, and so on, herbal medicine products, water pipe smoke, environmental contamination and pollution in different forms. And here's 10 chemicals of public health concern according to the World Health Organization. Arsenic, cadmium, lead, and mercury, there amongst them. Arsenic is naturally present at high levels in the groundwater of a number of countries, and long-term exposure to arsenic can cause cancer and skin lesions, cardiovascular disease, and diabetes, and can negatively impact on cognitive development and increased deaths in young adults. Cadmium exerts toxic effects on kidneys, as well as skeletal and respiratory systems. Mercury is, of course, toxic to human health, posing a particular threat to child development in utero and early in life. It affects the various systems throughout our body: nervous, digestive, immune system, lungs, kidneys, skin, and eyes. What about lead? Lead is a cumulative toxicant that affects multiple body systems and is particularly harmful to young children. And health effects are ranging from severe effects, miscarriages, stillbirths, increased risk of high blood pressure, kidney damage, and so on. Sources of lead here: mining, smelting, manufacturing, lead paint, and so on, drinking water. And some of these sources we can see also in the past. So let's look at Cyprus, where I'm located, a little bit about its contemporary context. Here a paper looking at arsenic, which is a major threat all over the island in terms of Cypriot geology. And the status of arsenic pollution is a subject of several papers. Copper is something very interesting to look at in Cyprus. Indeed, the name of this particular metal, copper, derives from es cuprium, cuprium being an es cuprium meaning the metal of Cyprus. So Cyprus actually gave its name to this metal. And Cyprus was one of the largest centers for the production and trade of copper from the beginning of the second millennium before Common Era until the fall of the Roman Empire about 1,500 years ago. And copper was exported widely from Cyprus throughout the Eastern Mediterranean and the ancient Near East, or Southwest Asia, if you like. Cyprus is littered, if you like, by large ancient slag heaps, size of hills. There are 40, more than 40 of them throughout the island. And mineral medicines are also referred to in ancient texts, these being salts of copper, iron, and zinc. And people came from outside Cyprus to source these mineral medicines from Cyprus. Here you can see an oxhide ingot, a copper ingot, very large ones that were traded from Cyprus to the region, and these have been found in shipwrecks from the Mediterranean. Now, let us look at a few case studies on metals, health, and beyond, and the role of synchrotron radiation enabled bioarchaeology in the region. So here are the three sites that I will talk about. Şehresuhte, which was in full swing about 5,000 years ago, a Bronze Age site from the current day region of Iran, near the Afghan and Pakistan border, where I had the great pleasure of excavating with my colleagues, Professor Mansour Sajadi and Farzad Foruzanfar. Heliopolis, a site that derives from the Roman period, and the material from which I work together with my colleague, Dr. Ali Metin Büyükkarakaya, and Hala Sultan Deke, which is slightly earlier, a late Bronze Age site from Cyprus that was in its heyday about 3,500 years ago, where I am in charge of the human bioarchaeological remains and their recovery in collaboration with the overall excavation director, Peter Fischer, and his co-director, Teresa Bürger. So let's go to look at ancient human hair from the site of Şehresuhte. And here you can see how the site looks like now. It's covered with sand dunes, but in the past there would have been a large lake, and it was along major trade routes that you can see in that insert, black and white insert on the slide. Some of those trade routes known now as the Silk Route. Here's some of the material culture, metal artifacts, cosmetic containers there in the bottom right corner. The red circle on the top left image notes the location of the cemeteries. And in the top left corner of the slide, you can see a very staged mortuary context. If you look very carefully, you can see in the hand of the skeleton in the left a stylus, which was for application of pigments. And of course, some of these pigments have very interesting range of metals, from lead to arsenic to copper. The cranium that you see in the middle of the column of images on the left, you can see that there's still some hair adhering to this cranium. And it was this hair that we started looking at, and I started looking at in the context of the extensive metallurgy, crafts work, and cosmetics use on the site. Here, note the metal mirror still preserved in its wooden box, and the pigments on the pottery. Craft activities were indeed so important in this site that, as mentioned, mortuary contexts were staged in such a way that identity of people as crafts experts was highlighted. Here, a pot containing pigments and a stylus. Now, I took the hair from these individuals to the European Synchrotron Radiation Facility. And I will talk you through the research and the results that we subsequently published. Here, some images from the field with the recovery ongoing with my colleague Farzad Foruzanfar and myself in the background, prior to being able to export these samples and take them to the ESRF to look at metal exposure. And the analysis of metal element levels are key to understanding human health during periods and on sites with intensive metallurgical activity. I would like to highlight that archaeologists use metals in their nomenclature for the time periods in our past civilizations in their development. We start with the Stone Age, and then we go to the Chalcolithic, which of course comes from the word chalkos, referring to copper. And after that, we come to the Bronze Age, where copper is used in context with other metals, making it possible to make better tools, better weapons, and so on. Followed then by Iron Age. So our progression through the human past is talked about in terms of our uptake of use of particular metals. Now, the particular questions that I set out to explore in terms of Shahr-e-Sukhte, which means the burnt city, was to look at to what extent we can trace metals in human tissues, and if so, are there elevated levels? Are there differences between individuals? And then, of course, what might these mean? And particularly focusing on copper. So here's that cranium with the hair remains and the microscopy, light microscopy images of those hair strands, as well as SEM image of those hair strands here seen adhering to the cranium. So these we embedded and then made cross sections together with modern controls. I had 8 individuals with hair remains from the site. And then I used synchrotron radiation micro-XRF mapping of the localization of the metal elements in these individuals. And here you have representative cross-section images in terms of the chemical imaging, chemical mapping of these cross-sections. Note the one with the intense red. This is a hair cross-section, think about 70 to about 100 micrometers diameter. And you can see that this one individual stands out in particular. There's significant differentiation. And this hair belongs to a young female in her 20s at death. And it's very interesting to look at the individual values and look at these values, particularly in the context of other individuals from the sites. The importance here is that we are able to look at the localization of copper within the hair section to also make inferences as to the biogenic rather than diagenetic or environmental uptake of metals in this particular hair. Some of the sources for this type of metal element presence in tissues such as hair can include, of course, soil contamination and its effects on food and water, craft activities, pigments, cosmetics in contact with skin, or any combination of the above. And interestingly, individuals buried close to the individual, the 20-year-old female, did not have values anywhere close to hers. So just to acknowledge the people involved, the funding bodies and so on involved in this study, I'm very grateful to all of them and for their collaboration and support. Now let's move to our second case study today, and particularly looking at metals in bones and teeth this time, and at SESAME, at the XAFS XRF beamline. And this work was indeed the first official beam time at SESAME, and I was very happy to bring my team to the beamline to work together with the principal beamline scientist, Meshaud Harfouch. It was particularly interesting to work and rewarding to work with a very international team, all of the team members, save Meshaud, based at Cyprus Institute, to look at the past people and their remains from the SESAME region. Now, we looked at bones and teeth, and particularly looked at differentiating arsenic and lead, which we can't do in the laboratory context, using here SR-XRF at SESAME. And I was also very interested in speciation that has relevance to the human health interpretation of these results. And just to acknowledge the number of individuals involved and funding bodies involved in this study, more to follow on that in the future. Our third case study today that I'd like to look at with you involves infrared. And again, returning to hair, but this time from a different site, the site of Heliopolis, Roman period. Hair from an individual from there. And hair, of course, from archaeological context has high analytical value with great potential for analysis of a number of different factors that you can see on the screen. But for these to be possible, a number of them rely on organic compounds and their preservation. And therefore, we need to evaluate this. So here's the location of Heliopolis, now a reservoir there. And the approach we took together with my collaborator, Dr. Jihan Kamel, a principal beamline scientist from the infrared beamline at SESAME, was to look at the organic compounds, to map them using SR-FTIR. And we discovered that while keratin in the samples were more degraded in comparison to modern reference samples, the results point to clear potential for further analysis with techniques relying on organic compound preservation. And we, of course, had some modern reference samples, and you can read more in this particular publication here, should you be interested. And this also happens to be the most recent cultural heritage publication from a SESAME beamtime, just about 12 days ago. Out now. And here the acknowledgements of the people and colleagues involved in this study and publication. So to wrap up, let's look at the future. Here's a project that one would perhaps not normally think about in the context of physics and synchrotron radiation use. It's called Face to Face, Meet an Ancient Cypriot. And the remit in the funding call was to take research results and translate them into economic advantage for Cyprus, and in this case, in the domain of tourism. Now, you might wonder how that works. What we do is making research results, including synchrotron radiation-enabled research results, available to the general public, whether it is local Cypriots or international visitors, through a focus on ancient Cypriots, their life stories, using synchrotron radiation approaches. And a major National Museum exhibition is coming up at the Cyprus Museum towards the end of this year. And the project also involves tailor-made tours and experiences inspired by past life stories of real ancient Cypriot individuals that we discover within the project, conducting human bioarchaeological investigations powered also by synchrotron radiation approaches. If this interests you, do get in touch. A recent SESAME beamtime following up with this line of work is focusing on Hala Sultan Tekke, which is a late Bronze Age site in Cyprus, and I will show you some materials from that site. We are currently analyzing the results from a SESAME beamtime on these remains, and I will excavate more with my team in a couple of months' time in May this year. And here I would again like to very much acknowledge the excellent collaboration I have with my colleague, Professor Peter Fischer from University of Göteborg, Gothenburg. And here is the data acquisition in progress at SESAME. A little bit about Hala Sultan Tekke, just to give you a feel of the rich cultural remains 3,500 years ago in this large urban settlement along now what is called the Salt Lake, which would have, of course, in the past been a sea bay, protected, an extremely useful location for the international trade that Hallasuutanteke Bronze Age site engaged in. So our work is located in area E that you can see towards the right of the image there, many tombs and burials there. And as you can see, there's a lot of metal work, lotus pendant here, a metal case that potentially contained cosmetics, and a lot of other rich material with pigments and colorants that in the case of pigments may have contained and indeed contained metals. Metal work was conducted on the site itself, potentially exposing the inhabitants to metal fumes. And this is indeed what my work and my team's work focuses on at the site. And we look at individual life stories as well. This particular gold diadem and these beads here, gold beads and golden earrings, were found by us during the last season of excavation, worn by a 5-year-old child. Here's some of the copper slag from the city quarter itself, city quarter 1 on the site. A lead object potentially need to be analyzed, a lot of work to still do, and various other items from the site. And here I'd again like to stress the importance of moving from the field, the excavation, the dirt, if you like, through consecutive levels of analysis at different scales, macroscopic to microscopic, to all the way to synchrotron facilities, looking at structural and chemical analysis. And here, a key enabler in our region are, of course, the laboratory platforms and facilities that we are and have been able to set up. There's more to follow. I'd just like to highlight here a couple of things in addition to the Biomera and face-to-face projects. The COMILIS project, which stands for Correlated Multimodal Imaging in Life Sciences, a cost action in Europe within the framework of this. And together with one of my PhD students, we're looking at ancient skin, including infrared analysis at SESAME, as well as data capture on metal content that I have completed at the SESAME XAFS XRF beamline. New projects also involve contemporary samples, plant, animal, environmental, and contemporary human samples. And if you're based in the region, or beyond, indeed, and interested in the past or present human metal exposure, do please get in touch. And then, of course, I would like to thank all the members of my research group at the Cyprus Institute. And it's a very international bunch. I'm very privileged to have the pleasure of working with these remarkable young ladies, and I would also like to thank very much all the synchrotron radiation facilities, the beamline scientists that work with us and tirelessly help us to explore the human metal exposure in the past, including during the pandemic, during these challenging times, as shown here. And of course, a number of other individuals, key individuals, and projects that have provided funding at Synchrotron Radiation Facilities, where I have been able to capture data relating to this line of study. Finally, take-home messages. Metals enabled humanity to become what it is today, but not without a cost. And Synchrotron-light enables us to explore human health in the deep past, as well as in the present. And in this, SESAME plays an increasingly important role. And I thank you very much for your attention.
Oh, so I cannot restart so the video, but at least so you can hear me. I think the host now is Andrea. I don't know what happened. So thanks so much for this wonderful presentation. So we really had a nice view of all this tour of the history. So trying to find all those little details of human that can really explain everything. So thank you so much, Kirsi. So maybe we could have a look at the question and answer. And we really have the honor of having a wonderful, not panel, because unfortunately I cannot show and have you to speak, but we have here so the honor to have Charles Bennett and Fahim Karimipour with us, SR-XRF. So I think it's really interesting to get the possibility to see the question and to answer to them. And hopefully, so in April, we will have possibility as well to directly share with them, so the microphone and the camera. So the first question, so that we had, so from so Charlie Bennett, so was to try to understand in the context that you are giving for the bioarchaeology, the speciation, so refer to the, if it does refer to the isotopic component rather than the usual meaning in biology. So, and he might have had in between, so some check through the internet. So maybe first I have you to explain what this would be, and then we can cross-check if it means the environment, so meaning for an element, or rather for this isotopic composition.
So yes, tell me.
The speciation. So what does this mean?
So in our case, what we are interested in when we look at speciation in this context is how does the particular metal species, if you like, affect our health. So any aspect of the and definitions of speciation in that context, in terms of its effect on human health, are relevant for us.
Okay, very good. So it means that yeah, this idea of how to get this interpretation is was correct. So then we had a question for another expert as well on quantum computers. So I guess that you may have recognized as well their name. So Vahid Karimipour was presenting in September, as a matter of fact, this physics matter, which was explaining how quantum mechanics as well had an influence on everyday life, and the definition of what quantum computers, as Charlie Bennett had developed earlier. So he had now this interest in trying to understand for the metal. So in the slide that you presented with the cadmium, so there was a photo of a fish with this cadmium. So what is the relation? So does it mean that the cadmium has an effect on the sea life?
Okay, let me try to see if I can go back to the particular slide so that we can, and I'm not quite sure if what view you can see. Can you see the full slides, or is it covered with the comments, Christine?
That's a bit, I count about like around 20, yeah.
Yeah, okay, let's try here. Here.
Yes,
okay.
Exactly. That one.
So we're talking about mercury here, okay? Now I think the question was about another metal, yes? Yeah.
Exactly.
Let me see if there was, okay, so cadmium, here's an image of the batteries. Maybe there is some let us say, well, mercury and the fish, of course, marine life is something that we all know are linked and connected, and we all need to be conscious of this and careful about what we consume and how often and so on. So I'm not quite sure what the cadmium and fish refers to in this context.
Really mentioned mercury, so that was a mistake. So he just put it now. So thank you very much for the comment.
Right, you're very welcome.
Very good. And then, so from Sekasi, so he would like to understand so the difference between the bioarchaeology and the paleontology. Paleontology and bioarchaeology.
So okay, so this is a great question actually. Paleontology tends to focus on, well, let's start with the bioarchaeology and human bioarchaeology. So human bioarchaeology refers to remains of archaeological human remains, let's say, from archaeological sites from more or less the past 10,000 years or so, at least according to Larsen, that gave the definition that we looked at in the beginning of the presentation. There can be, of course, some extension to this timeline. Paleontology tends to look at somewhat deeper past and also other animal species, if you like. Does that go some way of answering it?
Yes, I think it is. I think it is. Then I will add, like, what about the paleoanthropology?
Okay, so paleoanthropology is a great question. There are many names for a loved child, if you like. So there are a number of different terms that are used when we are looking at human remains and early human remains and so on. So anthropology, paleoanthropology, human bioarchaeology, osteoarchaeology, and so on and so forth. Paleoanthropology, if we start pulling it apart as a word and as an expression, paleo, of course, means old, and in this case refers to very old, and anthropology or anthropologia, since we are based here in Cyprus today, it is the science or knowledge of humans. So in this case, it is the very old remains, the remains of our ancestors in the deep past that paleoanthropology would focus on. However, you will find that many of these terminologies have slightly different meanings in different contexts, conferences, perhaps in different sides of the pond, so to say. The important aspect, of course, being those key questions that we can all answer together in an interdisciplinary context, looking at the human remains through synchrotron radiation techniques, but also in the context of other materials that I've also shown you today.
I think it's an excellent answer as well, and it leads as well to this forum that we will have to try to link. So what human really means in terms of all those aspects from the past to the future. And so we have maybe in the same tactile before we answer the question from Nazani. Maybe Alan, did you have a question as well? I think on the technical aspect. Huh?
Yes, I was very impressed by the entire talk, but especially the section that Kirsi presented on human hair samples and the sections for the case study being copper. Have you been able to extract a time series of exposures from a human hair strand of ancient remain?
This is indeed something very, very interesting that I would like to explore further in the future. We have done some preliminary work already, and human hair is, of course, lending itself very much to this, let us say, time-controlled in the sense of an individual's lifetime type of exploration. And I would also note here, in addition to other tissues with different turnover rates, human bone turns over in about 10 years, if you like. So that gives us the record from the past 10 years. Human hair keeps growing even after we die, just a little bit. So we can really get the last final days and the period around death from this particular human tissue. And then there's, of course, if you think about teeth and when the dental enamel forms, this has, again, another record. So therefore, it's very interesting to look at all these things together. And indeed, hair gives us an entirely different resolution, if you like, in an individual's lifetime, in terms of an individual's life story or biography, if you like.
I'm glad you brought up teeth because the archaeological community has had great success looking at isotopes to identify what is the source, the actual mine from which metals have come, and therefore where the individual grew up, let's say.
Sorry, the line was cutting up a little bit, I'm afraid. Would you be so kind as to repeat?
Sure. Yeah, that it's possible through nuclear techniques to identify the isotope mixtures of these metals and therefore identify the location of the individual, where they grew up, where they moved, and so on.
Indeed, and all of these techniques together are actually very interesting and important to us when we look at the individuals or the populations and change through time. So looking at these different sites, what's happening at different time periods, different contexts. And I've highlighted here the synchrotron radiation approaches, but that said, it is very important to conduct these in a context of multi-method, multi-approach investigation. And as I mentioned, human bioarchaeology, in my world, if one could put it that way, is really about applying every technique that can give us some cues about the past. It's a detective work in a really, let us say, deep past context. And in some ways, we can also look at things like human metal exposure in a much larger time scale and window that we are able to in our contemporary contexts. And one comes across many who think that metal exposure is something that is a problem of our own age. But of course, it's not. It's something that has affected us through time. So really a multi-technique, multi-method, interdisciplinary transdisciplinary and an international global effort, really, including, of course, physics. In that effort is required for us to understand life in the past and some of the challenges that people faced in terms of their health and otherwise in the past.
I think it's a very nice and complete answer, which is really good for the next question that we had as well. So from Nazanin, so who will try or want to understand, so is and how, so did this existence, so the existence, of such an international research facility like the SESAME change the dynamics of the collaboration in the region?
Christine, I could hear part of the question. Would you be so kind to repeat? I'm sorry.
The question is, so how did the existence, I think, of such an international research facilities like the SESAME change the dynamics of the collaboration in the region?
This is a wonderful question, actually, if I may, if you'll allow me, I will try to skip and hop to a slide that hopefully illustrates this also in terms of the dynamics, looking at the younger generation of researchers coming to this region from all over the world to look at some of these issues together, in this case with me, but also the potential of SESAME to contribute to such analysis and such efforts in other domains. So here, these young ladies, and I'm not sure if you can see them, but they really come from different parts of the globe. We are missing North America, Africa, and Antarctica. So if you're interested, come and join us. But I think it's a good illustration of how SESAME can also draw people from different backgrounds and different parts of the world, different backgrounds in the sense of disciplines, but also cultural backgrounds, geographical backgrounds. And brain drain is one of the key issues in our region here. In this case, I think SESAME can also act as reversing some of these effects, unwanted effects of brain drain. And in that sense, I think SESAME has a lot to offer, both in terms of excellence in science, but also science for peace, peace for science, and being a catalyst for more and more projects that can draw people to this region. I don't know, Nazanin, if that answers your question.
Yeah, I think it does. Unfortunately, she cannot speak because we are missing this function today. So sorry for this technical difference from how it was before. But I think she will be part as well of the panel that we'll have on the 28th of April. So it will be really interesting to elaborate on this aspect. And thanks a lot for this message. Indeed, the peaceful world, I think this is what we all aim at, especially today or with the coming situation. So thanks a lot for all those questions and answers. So maybe I will just finish to again record. Yes.
Andrea has a question.
Oh yeah, please, Andrea, can you speak up?
Yes, can you hear me? I hope, because I cannot. Yes. There is this strange thing that either you or me can be on a video, but so I just wanted, I didn't have a question. Thank you very much, Kirsi, for this wonderful presentation, but I just wanted to add a slight comment to the very last question about, so I'm not bold enough to say that SESAME, as young as it is, has already made a real dent on the circulation of science in this region. But I think that, especially in the context of archaeometry and these kind of studies, the fact that we are going to study a common past in this region, that will be also a key of circulation of ideas, because the boundaries are different, change over the centuries, over the millennia. So once you are digging, you will be digging things which come from different patches of history. Yeah. So that will also make people come together in this kind of studies.
Absolutely, and thank you very much indeed, Andrea, for joining. It's a great pleasure to have you here, and I hope I have given you some ammunition now to feel fully comfortable to note this aspect of SESAME contribution.
Thank you, Kirsi. Yeah, it's always very tempting to point out how much SESAME could do for these kind of studies, but there are really so many other possibilities of SESAME that still have to be used, and I sometimes have the tendency to focus, especially in this period of my life, on archaeometry, and we have to consider that there are many more aspects of SESAME available. Thank you.
Absolutely, and I think that is the key message also in our region. Any samples, any material samples with relevant key questions about our world, ranging from human health to geology, to energy, and so on and so forth. The opportunities are really limitless, and I think in discussions and conversations here in Cyprus with researchers from different domains, as well as conversations and discussions with researchers from the SESAME region and beyond, I think it's really very pleasing to see researchers starting to appreciate the potential of SESAME. So thank you very much indeed again, Andrea, for pointing that out. I think that's a very important point to make. Our topic today is one part of what SESAME can do in this region, but perhaps we could characterize it as only a tip of the iceberg, though we're not quite in the climatic region for that metaphor.
Yeah, in terms of the topic, but in terms also of all the different disciplines. And as you said, it's a pilot case, I would say, for the SESAME. So it's really important to see how far we can go as well in the quality as well of the measurement that the SESAME can provide. So I think it's a very good and important complementarity to all the different light sources that we have in the world. And especially, as you said, to unify the different country and the students, and to get really the capacity of building new community and dynamic community as SESAME is doing right now. So really an important image. So thanks a lot again. And as we mentioned, so on the 28th of April, so we will host this forum, so where the different panel of experts will gather with the audience, and they will be able to share the insight on the topic of human heritage and how science can impact human heritage. So for our past, for our current life in terms of human, but also hopefully for the impacting on the future. So how science can unify mankind, we could say. And so on a normal day, so everyone has a busy schedule. So in this new world, so where science enable new technology, so to improve our society and our civilization, as we have seen today, the evolution. And speaking about new world, so or brave new world, so the topic for next month so will be artificial intelligence. It's a lot of food for thought, so combined with the presentation today, and we will connect it as well to other important topics. For instance, like with the quantum information, quantum computer, we can even think about the cyborg or anything that could develop in terms of paleoanthropology, phase 1 up to the different phase that we're living on and what future will be. And we'll try to see how it can have an impact on everyday working life as a human, but also in terms of indeed this future. So I will, so this will be on the 21st of March, so next month. So we will have, an observer country presenting, so with Sweden, and it will be so Professor Kalle Armstrong, so from Lund University, who will present so how physics matter in artificial intelligence, so natural and artificial cognition. So I think it will be a very important topic so for many of us as well to try to foresee what future can look like with artificial intelligence. And so as we had also, I will just compare it as well with our list and recall the September presentation that we had for the paleoanthropology. So everyone can find a lot of material that we could discuss then in April. So that's, I think, most of the information that we wanted to share today. So if there are more questions, you can always contact us at physicsmatter for gmail@gmail.com, and we will be happy to meet you again. So in March on the 21st, and have a live panel discussion as well. So with Kirsi, Giham, Nazanin, and ESRF, and hopefully so with the links with Lund University and gather much more expert with all the different discipline and aspects that can help us to understand our human heritage. So thank you very much. And so we're gonna stop. So today, thanks again, Kirsi, and for everyone as well to have participate. And we look forward to hearing more for you in April and in March, so to hear about artificial intelligence. And we are welcoming, of course, so our special guest, so Vahim Karimilpour, and so Charlotte Bennett. So if you can attend, and Sekasi, so it would be an honor as well to have you discussing artificial intelligence too. Thank you very much, and have a good day. Have a safe day. Bye, everyone.
Thank you for having me. Stay safe.
Yeah, stay
You
safe.
too.
Exactly the word. Take care.
Hey.